Okay, students, so after learning key terms and the graphs, all the types of graphs, now we are heading towards the Stewart equations and then free fall motion. And in the last, we will discuss about projectile motion. So let's start. So students, we also call it equations of motion, but in our IB curriculum, we call it Stewart. Okay, Stewart equations. So this letter S is for the displacement covered, U is the initial velocity, V is the final velocity, A stands for acceleration, and T is the time. So in the kinematics equations, with the help of these equations, V is equals to U plus AT. This is the first equation, and total I will write four equations. If you apply you can solve any constantly accelerated motion problem with the help of these equations. Okay, so the second equation is S is equals to ut plus half at square. Okay, the third equation is final velocity square is equals to initial velocity square plus 2a times displacement. And you can also find displacement by multiplying the average velocity. So S is equals to U plus V over 2 times T. So remember that the condition to apply these equations, what is that essential condition? The essential condition is that acceleration must be constant. So when we say acceleration must be constant, we can also give it abbreviation UAM, uniformly accelerated motion. Now this constantly accelerated motion can be one dimensional and two dimensional. I will explain you later, but first I want to show you the shape of the constantly. For example, if an object is moving with a constant acceleration, and if its acceleration is positive, then what will be the path of this object? So students, if I am saying acceleration is constant, positive value, okay, and it is accelerating in a one dimension, it's not moving in a curved path, object is moving in a one direction. So if this direction is on along x-axis, just imagine that this is a path of the object, and I'm assuming the ball which started from the rest. Okay, so if it is constantly accelerating, then you will see in every next interval it will cover more distance, as you see in the diagram also. So this is a shape of constantly accelerated motion. Okay, so if it is zero, so it's, you also know that when we have drawn its velocity time graph, so what was a velocity time graph? It was a proportional line. So its velocity will uniformly increase, but not its displacement. It will increase proportional to the time square. So students, this is the one dimensional motion, remember. Okay, because the object is moving along the x-axis horizontally. Now I'm going to show you another one-dimensional motion, but in which I would say that acceleration is also a constant value. Okay, but that value can be negative. Okay, but in the case of the free fall motion, so this is the constant acceleration motion, also 1D. So let's say if you release the object, like let's say a ball from the top of the building, you just drop the ball, what will happen? This ball will also cover more distance in every next second. Okay, I will explain you in detail about the free fall motion. So this is also one dimensional motion, but along the y-axis. So this is a direction of acceleration which is equals to negative g, and negative is due to the direction. So student, this was a one dimensional motion. Acceleration can be constant in the two-dimensional motion also, right? So if I give you the example of the two-dimensional motion, then the perfect example is the projectile motion. So for example, students, if this ball is thrown and it is kicked with some initial velocity, okay, at an angle theta from the x-axis, so what will be its trajectory under the influence of gravity? If you ignore the air resistance effect, so then this will be the parabolic path of this ball. So students, where at all the positions, not only at the maximum height, the acceleration is constant, as you see. So that's why even like we will consider this motion two-dimensional motion, that is projectile motion, also constantly accelerated motion, and you can solve any question of projectile with the help of four equations of motion that I had written. Okay, so students, now let's proceed towards the free fall motion special cases that will immensely help you to prepare your test and all of the stuff. First of all, I will quickly tell you what is the free fall motion. So free fall motion is the motion of object in which it moves with a constant acceleration due to gravity. With constant acceleration. Okay. Due to gravity. So I have shown not only to you the one dimensional free fall motion, okay, because this was free fall motion but 1D, but also the two dimensional free fall motion as well. Okay, now we are going towards the learning of the important cases. Okay, so let's take the first case. This is a special case that if you throw a ball, then how much time that ball will take to reach the maximum height. So I'm saying time to reach maximum height. Reach maximum height. So students, when you will throw this ball with some initial velocity u, it will decelerate because earth is pulling this ball down. So with the passage of time, its velocity will uniformly decrease, and we had already covered this graph in the graph portion. So in every next interval, this ball will cover less distance and eventually it will stop at the maximum height. So at this point, its final velocity is zero, right? So what I told you, because this is a constantly accelerated motion, so which equation we can apply? Why not apply the first equation to find out the time? So final velocity is zero is equals to initial velocity plus into acceleration due to gravity is negative g and the time t. All right, so you can take u on the other side. It will be negative u is equals to negative gt, and then we see that the time t is equals to u over g. Okay students, so this is a time that it will take to reach the maximum height. And then don't you think it will return down as well? So how much time? So if it is taking u over g time to go maximum height, it will take same time to reach the ground. So that's why the total time of journey will be 2u over g. Okay, so the next case is how to find the final velocity just before hitting the ground. So find final velocity, although you can apply law of conservation of energy also, but today we are discussing kinematics. So students, for example, if this is a ball that you have just released, you have dropped, okay, you are not throwing it down, so its initial velocity is zero, and when it will fall vertically downward just before hitting the ground at this point, what will be its final velocity? What will be that? For your MCQ paper, you can apply direct formula, or if they are asking you to find ratio of two quantities, these tricks and these special cases will be immensely helpful. Okay, so let us see. Why not? Because we are not given the time of duration, whereas the height is h. Okay, this is a distance covered, so v square is equals to u square plus 2as. This is an equation of motion. We want to find out the velocity, so let's take a square root, and inside the square root initial velocity is 0 plus 2 into negative g. Now look at this, acceleration is negative, whereas the displacement covered, look here, it's not a distance, as is the displacement covered, that is negative also. So negative h. So what is the equation we got? That is 2gh. So in exam, you can find the ratio of the two velocities, v1 over v2 is equals to ratio of h1 over h2. I hope you get the idea. Okay. Okay, students, now the next special case is if you drop the ball from the height h, okay, how you can find out the time of the journey of the ball. Okay, now this is the different from the case number one, in which we had calculated time to reach maximum height. Because in this question, if you are given in exam the height or the vertical distance, how can you utilize this information to find out the time? Okay, and I'm telling you, this formula or this trick is not only applied for this one dimensional motion, as well as the two dimensional motion. I'm talking about projectile motion, in which in the special case of projectile I will explain you which one. Okay, so students, its initial velocity is 0. Okay, we know the height h. You remember, we are applying SUVAT, so we have to see what variables do we know and what we want to find out. We are given the displacement covered, we have an initial velocity, we don't have a final velocity, we have acceleration, that is negative g, and we want to find out the time. So one equation that fits best for this one, and you will agree with me, that is s is equals to ut plus 1 over 2 at square. So if we put the values, what is the displacement covered? Once again, it is the negative h. Okay, because it has moved downward. Initial velocity is 0, that's why this term will become 0, and 1 over 2 into negative g into t square. So students, it will become equals to h is equals to 1 over 2 gt square. And I'm telling you, not only you can find out time, don't you think you can find out height as well if the time is given? Okay, because this equation tells us that the height is proportional to t square for this one dimensional motion. Okay, so you can utilize this proportionality as well, but right now I am focusing on the time, so time will be equals to square root of 2h over g. So students, you remember I was telling you that you can apply this equation for one case of projectile. I'm I think I should tell you here. Okay, if you hit the same ball horizontally, okay, like this, with initial velocity purely along x-axis, so this is the initial velocity u. So what will be the path? Now you see that actually we have moved the ball with, we have kicked the ball horizontally, so its initial vertical velocity is 0. This is a condition, right? I'm not talking about this projectile motion. Okay, so I'm talking about only this horizontal projectile motion. If the height of this cliff is h, then how much time the ball will take to reach the ground, if you want to find, so you can absolutely apply this equation, it will perfectly work. So students, these were the special cases of free fall motion, one dimensional motion, and now we are heading towards the projectile motion, which is very important topic in the kinematics. So students, projectile motion is the two-dimensional motion which occurs under the influence of gravity. So it means that if you push a ball, I mean, if you kick the ball, and then there's a no external agency that is carrying the ball. Okay. So the ball will adopt a projectile path. The ball will adopt a parabolic path due to the gravity. So it will attain the maximum height. It will cover the vertical distance, as well as simultaneously it will cover the horizontal distance also. Why do we call it two dimensional? Because the object covers both motions simultaneously. One dimensional was just along the x-axis or the y-axis, but this is not only horizontal motion but also vertical. I will show you in the diagram also. So I must write, I mean, if we summarize it comprehensively, don't you think we should say it is the two-dimensional motion due to the constant acceleration due to gravity? Under constant acceleration due to gravity. So object covers horizontal as well as vertical distance simultaneously. So students, now I will share with you the important types of projectile motion, and especially I will focus more on the the special cases, just like I had told you about the free fall motion. So the first we can say is the horizontal projectile motion. So students, in the first type, horizontal projectile motion, let's say this is a ball which is thrown horizontally. I had already told you that it is purely thrown horizontally, that it doesn't have any initial component along the y-axis. Okay, so its initial velocity along x-axis is equals to its instantaneous velocity. So if you have thrown the ball with, let's say, 20 meter per second, so you are throwing like this. Okay, but if you will throw at an angle, then the velocity will have both components, horizontal as well as vertical. Now due to this, the path of the projectile will be always parabolic due to the gravity. And the one very important assumption that we will consider, that we will not include any air resistance. Okay, remember that. Then only the definition of the projectile motion will be fulfilled. Okay. So students, important assumption that we are going to take is that we will consider there is a no force due to the air resistance. Okay. So when there is a no force due to the air resistance, then there will be only one force will be left behind that we can never ignore, that is a force of gravity. Okay, but the force of gravity, dear students, is the force along the y-axis vertically downward. Okay, that cannot be ignored. So the force due to the air resistance, if you assume there's a no air resistance, then this force, not only because this force may have the two components. So this force due to the drag force, okay, its y component will be 0 as well as its x component will be 0. Okay, now as I told you that the along the y-axis there's already no force, I mean there's already a force of gravity that cannot be ignored. So we will focus more on this force. So as a result of our important assumption, we will get this important result that there is a no force along x-axis, which will cause no acceleration along x-axis. Okay, in the x direction motion, which means that there is a no change in velocity in the x direction, which means that initial velocity as well as the final velocity is same, is constant. Okay students, so it means that at all the points this ball will have the same velocity. Clear? Now I'm just showing you the horizontal component. Don't forget that this ball is moving downward in a curved path, so its velocity, instantaneous velocity, is in this direction. So it means that it has a vertical component of velocity which is not constant, unlike the x component. So in fact this y component of velocity, dear students, this y component of velocity is increasing. And how it is increasing, I will show you. I will show you from the equation also. It is increasing due to the force of gravity. So just before hitting the ground, it have a maximum velocity at this point. Okay, whereas this is a final vertical velocity. Okay, students, so let's quickly discuss the x component, y component of motion, right? As you have seen that there's a no acceleration along x-axis. Okay, whereas the velocity also is constant throughout the motion. I'm talking about x component of motion, all right? But what about the displacement covered? So if you apply this equation, s is equals to ut plus half at square. Okay, so students, this is a ax, which I already told you it's 0. So what is a horizontal displacement covered, distance covered? That is also called range of the projectile, that how far it fall, okay, from the point of projectile, how far. So this is equals to ux times t. So this is a equation that we will apply in the questions. Whereas if we come towards the y component of motion, acceleration along y-axis is not 0, rather it is negative g. And what about the velocities? You have seen in the diagram, there's a no velocity along y-axis in the beginning because we have thrown along the x-axis. But what about the velocity, how it will change? I told you it's a constantly accelerated motion. We will apply equation of motion. So what if we apply this equation, v is equals to u plus ad? Okay, and if we change it, so vy is equals to uy plus ay. So students, what you see that the final velocity is equals to 0 minus acceleration is negative g and negative gt. So as the more and more time will pass, vertical velocity will increase more negatively. Okay, so that is the equation of motion. And how much will be the vertical displacement covered, dear students? If you apply this equation, s is equals to ut plus half at square, so you will get the same equation that we had made few minutes ago. So s is basically the vertical distance in this case. Okay, all right, which is the negative h. Okay, negative h is the height of the cliff, is equals to initial vertical velocity 0 times t plus 1 over 2 into negative g into t square. So are you remembering we made the same equation? So h is equals to 1 over 2 g t square. So students, now we are heading towards the next type of projectile motion, which is very important. If you throw the ball which makes an angle with the horizontal, then what are the special cases of projectile motion? Although every special case will come from the equation of motion, because the base is same, that is constantly accelerated motion. But I'm going to show you a detailed diagram in which I will show you how the instantaneous velocity changes. And remember, acceleration is constant, that is negative g. So students, if this ball is kicked in this direction, okay, so it have initial velocity u and it is making an angle theta with horizontal. So what will be the path of the ball? The ball will go to the maximum height and then coming back to the ground. So these are the different position of the ball. It will reach the maximum height, okay, and then now it is returning back and just before hitting the ground. Okay, so how its velocity? First of all, we can make its two components of motion, right? I mean, this is the u cos of theta. Can I say this is the x component of velocity and this is the y component of velocity, u sine theta. Okay, students, so we had already learned about the x component of motion. The u cos theta, which is any value, okay, will remain same throughout. Okay, so I will try to draw equal length of the vector along the x-axis. So student, this is all u cos theta. So if u is 20 and cos is 60, cos 60. So 20 cos 60 will be equals to 10 meter per second. So the 10 meter per second will remain 10 throughout the motion. But what about the u sine theta? So as the ball is going up, it is a free fall motion, ball's velocity is decreasing. So now its velocity at this point will be obviously less than u sine theta. And in fact, at this point, its vertical velocity has become zero, but not the entire velocity. That's why the ball will not stay at rest. Okay, this is the difference between 1D and 2-dimensional motion. So what will happen after that? Now the ball's velocity will increase, but negatively. Okay, and just before hitting the ground, it will be, remember that, it will be negative u sine theta. Okay, that is the uniform increase and decrease. So as the ball is going up, it has decreased, and now ball is coming down, it will increase by an equal amount but negative increase. Okay, so that's why I have written negative u sine theta. And what about, dear students, the instantaneous velocity? Instantaneous velocity will also change. Okay, the ball is going up, instantaneous velocity will decrease, and when the ball is coming down, it will increase. And you can find it with the help of Pythagoras theorem at any point. So you have this value. Okay, you can find out, for example, at this point, you, if you want to find out what is the instantaneous velocity, so just take the components, square, u cos of theta square plus u sine of theta square. Okay. All right. So if you have values, you can put in this Pythagoras theorem equation and you can find out the initial velocity or instantaneous velocity at all the points, at any point. So students, are you ready for the special cases? So there are three cases. Okay. There are three formulas important, which is only valid for this projectile, not the other one that I had already told you. This is called range. Okay, let's write it with R. Okay. These equations will specially help you in the MCQs. Okay. And this is a height. It is the vertical distance. Okay. All right. So we will try to make the equations with the help of equations of motion, right? So first of all, let us apply the equation of motion to find out the time. Okay, students, to find out the time to reach the maximum height, we will use the vertical component of motion. Okay, because vertical component of motion is affecting the time. Okay, so in a vertical component of motion, dear students, you know the initial component of velocity is u sine of theta. All right. Remember that we will never use the instantaneous velocity. Either you will have to use x component of velocity or y component. So at the maximum height, the vertical component of velocity is 0. So I'm assuming it is my final position. So vertical velocity is 0. So if I want to find out the time, so which equation should we apply? So we have, don't you think the simple this equation vy is equals to uy plus ay into t. Okay, so we have transformed first equation for the y component of motion, and now we have to put the values. 0 is equals to u sine theta, it's positive because it's upward, minus gt. Okay, now this t is not a total time of journey, it's a half time. So gt will become equals to u sine theta, and finally the time is equals to u sine theta over g. Okay, now if it is the time to reach the maximum height, which you remember was u over g in the one dimensional motion, but in the two dimensional motion it is u sine theta over g. So don't you think the total time y must add, because it will take the same time to return. So for the total time, that will be equals to 2u sine theta over g. Okay, student, let's now find out a formula that will help us to find out the range, horizontal distance. So the horizontal distance, if you will throw the ball with more and more horizontal velocity, it will cover the same time. Okay, it will cover the same time because time is proportional to the height, square root of height. But it will cover more horizontal distance. So basically, while we will be finding out, for example, you can apply this equation, s is equals to ut plus 1 over 2 acceleration t square. Okay, this will help us to find out the range. So I'm calling the s the range because this is the horizontal distance, and I'm going to use the x component of velocity times t. Now this time t, now this time is the total time. Okay, the total time to cover the horizontal distance plus 1 over 2 ax t square. So students, ax is 0, right? We have a very good understanding that, and the ux, you remember I had made the components of velocity times t was, the total time was 2u sine theta over g. So in fact I should use the capital T here because this is the total time. So students, it will be r is equals to u square, and inside bracket we have 2 sine theta cos theta. Okay, I'm going to turn it into the double angle formula and divide by g, which can be written as u square over g. This 2 sine theta cos theta can also be written as sine 2 theta, remember. Okay, so sine 2 theta, this is called double angle formula, and from this we get a very important information that if any projectile is thrown at an angle 45 degrees, it will fall at a maximum horizontal distance. All right, so this is very important point. So it will be simple u square over g, because sine 2 into 45 will be sine 90, and sine 90 is 1. Okay, now we are heading towards the third case, in which if you want to find out the height of projectile, how can you do that? So students, for this, once again, we will assume the y component of motion, okay, because height is actually the y component of motion, and the vertical velocity will play pivotal role to understand how high the ball will go. So if you are throwing with a maximum, like more and more instantaneous initial velocity, that will have a more and more vertical component of velocity. I'm talking about u sine theta. All right, so if u sine theta will be greater, the ball will be able to go the maximum height, more and more height. Okay, so this is a trajectory of the ball, okay, to the maximum height. So you remember this was the y component of the initial velocity. So this is the u sine theta, and which is, by the way, at the maximum height is becoming 0 meter per second. So what will be the height of the projectile? Let's find out, with once again with the help of equations of motion, and the good equation, because if you don't involve time in this calculation, so this is the only equation that will help us. So v square is equal to u square plus 2as. So I'm going to write it in the terms of vertical motion. So vy square is equals to uy square plus 2a phi and capital H, that what we want to find out. So that is 0 square is equals to u sine theta, okay, plus 2 into negative g into h. All right, now you can take this negative term on the other side and it will become 2gh, whereas it will be u square sine square theta. So students, finally the height is equals to u square sine square theta over 2g. So I have made the three formulas for the projectile motion in which the ball is thrown at an angle. These three formulas are only valid for this kind of projectile. Okay. Now, last but not least, I will show you what should be the graph for the vertical and horizontal velocity, because that is also one of the favorite question. So students, we have learned that the x component of velocity will remain same. Okay, so that's why throughout the motion, throughout the time, it will be like this horizontal line, and this point is of course u cos of theta. Okay, but what about, and this is a time, okay, this is a time and when it is returning or it is hitting the ground. Okay, it is falling the ground. Now, during the same time, what about the vertical component of velocity? We have seen in the start, the vertical component of velocity was maximum, right? When you have thrown the ball, that was a u sine theta. And as the ball goes up, it decreases and it becomes 0 at a maximum height. And when the ball comes to the ground, now the vertical component of velocity increases negatively, that we should see from the graph. And this is a velocity I'm talking about, not the speed time graph. So of course this value, dear students, is u sine theta. This is a time when it will reach the maximum height where the vy is 0. Okay, and this is a time when it is returning to the ground, and it is once again negative u sine theta. Okay students, after the lot of effort, you can see on my screen this is a whole concept map as well as review, a detailed review of kinematics topic, and this is just the beginning. I will try to improve more and more, and very soon I will show you, with the help of my videos, I will show you the concept map of the mechanics, waves, thermal physics, fields, gravitational, electric and magnetic fields, as well as the modern physics, nuclear physics as well. So just stick with it and kindly give me your worthful feedback. and you can access this PDF. I will drop the link below of the video.